Okay, number 33 is asking us, giving us the zeros and asking us to write a polynomial equation, function rather, with the given degrees and zeros. So, if your zeros are x equals -1, x equals 2, and x equals 1 minus 2i, the first thing is to realize that if x equals 1 minus 2i, then the conjugate is a 0 as well. So we have, those are our 4. What we'll do is we will set them all equal to 0. So x plus 1 equals 0. Subtract 2, x minus 2 equals 0. I'm going to subtract this quantity from both sides. Don't have a lot of space there, so I'm going to rewrite it as x minus 1 minus 2i. I'll leave it in parentheses for now. And we'll do the same thing, so we'll subtract this quantity over here too. So that'll leave me with x minus 1 plus 2i. There we go. Okay. And these are each equal to 0. I don't really have that much space. Okay. So simplifying, we subtract 1. I'm sorry, I don't want to simplify. That would take me right back to where I once was. If each of these are equal to 0, then that means all of them multiplied together have to be 0, right? Now, the next move I'm going to do is an interesting one initially, but we distribute the negative here, and so we're going to get, and also here, so we get x plus 1, x minus 2, x minus 1 plus 2i, and x minus 1 minus 2i equals 0. And then what I'm going to do is I'm actually going to put parentheses around these. The reason why I'm doing this is because this and this match, and this and this match, and we have plus and minus, we have the difference of squares. So what ends up happening is this becomes x minus 1 quantity squared minus 2i quantity squared. The difference of squares is x squared minus y squared, the same thing as x plus y times x minus y. So anytime you have something like x squared minus 36, that breaks down to x plus 6, x minus 6. Essentially saying, what I'm saying is you could take the square root of each of these, write those values, and then just put a plus or minus. So hopefully that makes sense. Moving on, so those are in parentheses. Now the x plus 1 and the x minus 2, I'm going to go ahead and just leave those as is. You could distribute those out as well. I want to focus on these inner parentheses. So what ends up happening here is, push this up a little bit, what ends up happening here is we just clean these up. And so we have x minus 1 squared, we get x squared minus 2x plus 1. I hope at this point, if you're not seeing this, then I advise you to watch some previous videos where I explain where this comes from. Essentially, you can always just square this, multiply these together times 2, which is the middle one, and that gives you the term factored out. 2i squared becomes 4i squared, and I squared is -1, so now I have x squared minus 2x plus 1 minus 4 times -1. And that cleans up to x squared minus 2x plus 1 plus 4, which becomes x squared minus 2x plus 5. Now, the x plus 1, x minus 2, I'm just going to take that down. I think I said x plus 1, x minus 2. Let me check. Okay. And we're now going to, let's just go ahead and we'll factor that out. That's just going to become x squared minus 2x plus x minus 2, with the middle cleaning up to be x squared minus x minus 2. We'll bring this down as well. And so all I have to do now is multiply this out, and that'll give you the answer. I've run out of space, so let me do that on another page. So we have x squared minus x minus 2 times x squared minus 2x plus 5. What I like to do is I like to write these, one of them horizontally and the other one vertically. Like such. So I'm essentially doing what's, if you recall from high school, the box method. And we'll clean this up. So this is x to the 4th minus x cubed minus 2x squared minus 2x cubed plus 2x squared plus 4x plus 5x squared minus 5x minus 10. And you can see here that these, and these match up. So we can combine like terms and we get x to the 4th, negative 2x cubed minus x cubed is negative 3x cubed. 5x squared plus 2x minus 2x. The 2x squared is cancel out, so we're just left with 5x squared. Minus 5x plus 4x is negative x, and then we have minus 10. And that's my final answer. So it's a pretty nasty problem, takes some time to get through. The goal in this question is to initially, let me go back to the beginning. You want to rewrite it as this sort of function, right? And this is very, very important. Let me do this in a different color. This part right here, you want to make sure that you convert it into this format because it allows you to complete, use the difference of squares, right? Difference of squares. This is the formula for the difference of squares. And that allows you to easily get this down to this format. And then, once we have that, then all we're doing at the end is we're just doing massive foiling, or massive distribution if you prefer. And that gets me my answer. So, hopefully that makes sense, and I'll see you in the next video.